Um, yeah, I think you can see my screen, right? So if there is any problem in visualizing my screen while switching over, you can always stop and tell me. Any doubts, yeah, all are welcome to stop me at any point of time and tell me. So this is going to be the agenda. So it's more or like yesterday I also attended Sir's IIT professor session. It's I hope you could have got a mathematical understanding of that. So I have planned my session in such a way that it would be more of a practical aspect, so that I can better give you a baseline of how you can start working towards this machine learning or deep learning without more hesitation. So that's how I made this session, and it's more of a basic rather than an advanced level. So those who already have practiced with this, kindly bear with me for a few time. So initially I'll try to introduce what this domain is all about, and what are the buzzwords that are there in this industry, and we'll try to explore the basic packages that one should know before getting into machine learning applications. And two important aspects. See, we all used to work on Jupyter and Google Colab. I hope most of you are comfortable with MATLAB. Nothing wrong in that, but visualization is more easy and comfortable in Python. And any UI can be easily integrated into Python. So that is the advantage, and that we will see. And with that, we will look into it data set, and we'll see how what kind of pre-processing we can do and what pre-processing means to us, and how the training and testing data set could be divided, and all that we'll try to do it with the data set. So that's going to be the next 1.5 hours agenda for me. And to start with, I have a diagram with me. So a very classical example. Okay, earlier all of us would have got a phone which looks like something on the right hand side. So this is nowhere available now. Even a 60-year-old doesn't want to have this kind of classic mobile phone with them, right? All that they want to have is something on to the left. So this we call it as a smartphone always. So this is not called as a mobile or a phone or any way. Rather, it is being called as a smartphone. No one now. So it's not about the kids. Even a 5-year-old is able to operate. Even a 60-year-old is able to operate. So we want smartness, not a classic device everywhere, right? So how do you achieve smartness? That's my question. Can any of you, ma'am, can they unmute or else
Yes, yes.
is it not possible?
No, they can unmute. They can unmute.
Yes, ma'am. Can how can we achieve this smartness? Can I
by
have
decision making skills?
Yeah, thank you. So
By
it is about the decision.
making,
It's all
taking
about the
its own
decision making
decision.
skills. Yes, please. Anything else?
And able to carry out operations soon, have the computation in a faster manner.
Yes. So you want to complete the operations very faster and very effectively, right? So that is you want to do it in a more smarter way. Okay, so as and when we improvise ourselves, see, it's not that how I can deliver my content on my first presentation, right? As and when I get experienced, and if I take the feedback and get improvised more and more, my smartness will get increased. Okay, so that's how everyone, even if you go for an industry, it's not about the hard work that you are employing, rather how much smart work, what that smartness means, how do you achieve that smartness is the next question. How this classic mobile phone gets replaced with the smart mobile phone on a later industry. So how do you achieve this smartness, right? So anyone, as sir rightly pointed out, if you are able to complete a task effectively, so there is a difference between effectiveness and efficiency always. You are not, if you are too much efficient, we say you are a hard worker, right? So that means you are given a job, you'll be trying to arrive at a good output, okay, which is good for you, not for the client who has given a task for you. Rather, always smartness means you are trying to complete a task effectively, which means given you are working for the task you are given with, right? To a proper extent. So a client is giving you a job to do. Let's say you are trying to make a website. So you are not entitled to put forth your own area of interest over that. Rather, the end product has to be effective for the client for which he is doing so. So that completeness has to be done. And when you are able to do, or when you are able to complete the task effectively, so how can you able to complete that task effectively? As and when you gain experiences, right? So it's not that, and it's an understood fact that any 18-year-old or a 20-year-old or a 40-year-old is too much smart rather than a 5-year-old kid. Okay, not this generation, I'm just telling. So how the human beings are also gaining the experiences? It is through gaining the experiences on your day-to-day life, adopting and learning from the experiences which we get on our day-to-day life. With that, we'll be able to complete the task effectively. Initially, if you see this bar, which is on the middle, won't be in a balanced format. You will have ups and downs, right? So to start with, in our 10-year-old or 11-year-old, we'll have ups and downs. Any experience will not be enough, and hence you will you will not be able to complete the task effectively. But some point of time, it's for sure that the effectiveness will reach, and there will be a balance in our bar. This is where we call it as smartness, right? So when the human being is able to achieve this balance by gaining experiences, and which is reflected in completing a task effectively, we say the smartness is achieved, right? So from where do you, and how do you measure the smartness? Okay, so I say that I'm smart. Okay, how do you feel like whether I'm smart or not? You have hundreds of people attending an interview. If you are here to select only a few over there, how do you feel like a particular candidate is smart? Okay, always we have some metrics. See, a kind of that is, if you come for a school kid or a college student, okay, we have performance metrics which are nothing but their evaluation marks which they score in both the formative assessment, summative assessment, or in all the exams or assignments or whatever we have. Okay, that is the performance measure for a student. If it comes to an employee, we have our own performance appraisal, so which has different levels of assignment, so that comes under the performance metrics. So the metrics may vary from one individual to another individual, but on the whole, if you see, the performance matters. So always the measure has, that is, the smartness needs to be measured. If something is not being measured, that's not of use, because we don't know how to improvise ourselves on the next scale. So we do have to have a performance metrics for the domain for which you are working. So this performance metrics is not standard. You cannot say this scale has to be of the performance metrics for all. Rather, it differs depending on the domain you are interested. So how do you improvise this performance? See, ultimately, what is expected out of a guy is to have a better performance in whatever activity they do. So how do you improvise that performance? That is through gaining experiences. See, all of it is not only through gaining experiences, it is through gaining better experiences, we should say. Okay, so we would have seen the film called Pidamahan, okay, where Vikram is coming or getting grown up from a graveyard. Okay, so he is also getting experiences, but that experience we cannot match it with the guy who is getting who is growing on a better place. Okay, so experiences alone is not a matter of interest, whether you are able to give a proper experiences on a balanced scale. See, it's not that only good things has to be given to our kid. Okay, if the kid is able to balance between the good and the bad that are there in the surrounding, they can come up on a better scale. So this experiences matters a lot. Only through this experiences, the performance metrics can grow up on a proper scale, and the kind of experiences that you are going to enforce to your kid matters a lot. Okay, so that's what is about the scale of smartness. So we need to have a set of performance metrics, and this performance metrics has to be improvised on the experiences that you are giving. So that is about that. From whom is this expected next? Okay, so we all are talking about smartness. Okay, from whom is this smartness expected? From who and all? Okay, so we are not stopping with anyone. We expect this smartness from our servant maid who is not educated on a proper scale, to a 3-year-old kid who is at our home. And this lockdown is very, very problematic. So from where we are expecting a lot of smartness from everyone. Okay, so we are expecting this smartness from a human being on a scale. Okay, so that scale varies. You expect that smartness from your husband to 100, that is husband or a wife to 100 percentage, rather on your kid to a 50%, on your servant to a 20%. Okay, so the scale may vary, but we require smartness from every guy who are surrounding us. Are we stopping this expectation with the human being? No, we want all the devices also to be smart. Okay, we are not stopping the requirement with the human being. If that is so, you and me will not be there in this session nowadays. Okay, the smartness is expected from everywhere in all the machines that we do have now. Okay, so you use a washing machine, you go for plugging in a switch. Okay, so we all need automatic closure, automatic opening. So how does it come? It is through the machine smartness. Okay, so as and when this expectation increases, so how do this human gains their smartness? It is through learning. Like the same way, the machine also will get their smartness using this learning. So what is finally expected? So when human is learning, we say it is human learning. When machine is learning, we say it is machine learning. But anyway, it is all about only the learning. So learning gives you more of experiences with which you can improvise your smartness, right? And hence, what is machine learning? In short, we do say we'll try to collect experiences. Okay, these experiences will come from a different source of the domain of interest. Okay, and you collect these experiences. With this experiences, you try to do a task. What is a task? That is what for you are here. Okay, now today I'm here to deliver my content. So what is that I can do? I have to deliver my content in a proper way. For that, I should have collected my experiences from all the knowledge which I have gathered. Okay, so how do my task will get assessed? So nothing will go as such, right? Once I complete, you'll be getting a feedback form. So with that feedback, I can assess how my presentation is going to be today. So finally, the task which anybody do has to be, or anything do, not anybody alone, anything also, since it is a machine, has to be measured with a set of performance metrics, right? So this is all about machine learning. So by definition, this is that what are all expected for a machine learning is you should know what is the task you are going to do. Okay, so you have to be clear on the task of which what we are going to do. A sample is whether the person will like the movie. This is, see, whenever a producer is trying, that is releasing a movie, his focus would be to find whether this, how much of the crowd will be trying to, will be liking this movie so that he can get his revenue back. Okay, that is the task. So now that, how do you do this task? It is through experiences. How do you know whether a person will like the movie or not? It is through their watch history. Okay, what is the category of movie that they do? A lot of different parameters, we don't need to bother, but the only thing we have to understand is the experience. And how does this task gets evaluated? Okay, after getting released, how do the people know whether how many will be liking? So they can take back so many interviews later on after releasing. You match it with whatever you have already predicted. That's what we call it as the performance metrics. Okay, so this is by definition, and what we have seen here is by understanding, right? So with that, this is a small slide explaining what the exact difference is about traditional programming and machine learning. In traditional programming, what we do is we'll be trying to give the computer a program. Okay, this is a program I have written in C or any language, a sample language, to compute sum of two numbers. So this is the program, 4 lines of code I'm giving. I'll be trying to give the raw data. What is my raw data? It is 5 and 6. The computer will process this raw data over this program. Okay, 5 and 6 are my input. It will try to compute the third statement, and finally the output will be 11. So this is traditional programming. All that what the computer does is trying to process the raw data on the program and deliver the output. That's it, nothing more than that. Okay, in contrast to that, what is expected out of a machine? See, I don't want this program to be written by me because I don't have a stated algorithm for that. Okay, you have 1,000 people and you have a variety of data with you. I don't know what is happening with the data. How are they coming out with the output and all? Rather, I know that these, with this, they are this output. With this, they are this output. Okay, I don't know how to program it. Okay, that's where we end up with machine learning. What we do here is we'll try to give the raw data as input. See here, 5, 6 are my input, 11 is my output. Okay, 560 is my input, 56 is my output. Likewise, I'll try to tell the computer that I have this input and this is my output. I have this input and this is my output. Likewise, we do have. So once this data, that is the input and the output is given, automatically the computer will try to understand the pattern that exists between that. Okay. This is like in our aptitude training, normally what we do will be given with a series of data. 1, 3, 5, 7, and what's the next number in the series? Okay, it may follow an arithmetic progression or geometric progression, or sometimes it's on a different scale also. But rather, how our mind will try to do a comparison between all the data that are available. Since we know what is the input, 1 is my input, 3 is my output, 3 is my input, 5 is my output. So our mind will go on correlating all the data that we do have, comparing the inputs with the outputs, and finally say what would be the, or predict what would be the next data. It's prediction, right? So even if it is multiple choice question, give an answer, 4 answers will be given. You'll be trying to predict what would be the next number in the series. Sometimes it may go correct, sometimes it may not go correct. Fine, no problem. Okay. So that is how the machine learning works. You give raw data as input, you give the output, that the system has to understand the pattern over here and try to write a program of it. See, actually, it's not a program. Okay. So the output of machine learning will not be a program, rather it's an equation. This is for understanding, I'm telling. Actually, it won't give you any program of this kind. Rather, it's a equation that it will give. So now where comes the machine learning algorithms? Okay, so what is a necessity? Actually, you cannot directly find. See, the data is very quite easy here. It's just addition. So you don't need to bother. If you write y is equal to a plus b, automatically the output will come. Okay, but not all the data will be of this kind. You will have different linear. There may exist linearity. The data set may be non-linear. That may be variety of things that may exist between the input and the output. And hence, understanding might be easier. And hence, the evolution of machine learning algorithm came in. How do you effectively assess this input and output and come out with a program that can give you output for a newer set of inputs? Okay, so that's where we end up with machine learning. I hope the context is clear. So about this traditional programming and the machine learning, right? Now, how do you collect experience? That's the next question, right? So, okay, we all are talking about experience. So the task I know, because every one of us know after having taken a project or a research work or anything, okay, any type of work, we know what is the task that we need to do. And performance metrics, okay, we can assess it after deciding the algorithm. But the experiences is of interest. Okay, how do I collect my data set? If I don't have a data set, how can I create it? Okay, that's the next question. So how to create that? So I have a simple demonstration using the current pandemic. So this diagram represents a COVID-19 virus. So the entire world is getting into problem because of this. Now, what am I going to do? So if many people are there coming with the symptoms, okay, and there are many issues, the interest is on understanding what are all the major symptoms that is directing to the COVID, presence of COVID. Okay, so that's the task that I'm going to do. So what is the task? So we have to identify the list of all symptoms that is giving you, that is creating a lot of infection. Okay, so corona infection on the patient. Okay, now what I do, so in order to identify the symptoms, first we need to identify the features. Okay, so what is a feature? The list of all characters that contributes to this domain. This is about corona. So what are the features that contributes to presence of corona? Okay, so WHO has given. Okay, so if there is a presence of fever, if there happens to have a cough, and if there is a problem in breathing, and if there is exists tiredness, muscle ache, and the list is not exhaustive, right? You will have n number of people. This keeps on adding. So you don't need to have an exhaustive list in the initial stage itself, but this comes as your feature set. Okay, so for your problem domain, if it is prediction of solar radiation or prediction of how much current we can get from a solar, so for that domain, initially we have to identify what are the characters or features that contributes to your output. Okay, our output is the voltage, okay, that we can get from a wind energy. So what can we do? You have to identify how much wind is blowing, okay, and how many the windmills are there on a particular area, okay, what is how much is the area of open space that is available, okay, whatever you think is contributing to the output is what we call as the characteristic or the feature, nothing more than that. Now, once having identified this next step is to identify how to measure this, on what scale, okay. So some parameters, if you take, see, current will be measured on voltage, okay. I'm not good at electrical, but generally current will be measured on voltage, but there won't be some things where the units cannot be assured at all, okay. But you need to have a scale fixed. So the fever will be measured by either Celsius or Fahrenheit, right? So how much degree of fever you will have, the temperature. Cough, how many times are you coughing per second or per minute comes as the frequency. Do you have problem in breathing? Okay, yes or no kind of question it might be. Do you have tiredness? Do you have muscle ache? Okay, so this scale varies. You can have any kind. You can have numbers. You can have yes or no. Sometimes if you want to record the time from which the person gets fever, okay, that is also a measure where you have date. So whatever you name, you can have as a measurement scheme. But is the list exhaustive? No. With this is not at all enough. We need to have patient's name, address, history, everything. History in the sense whether they have sugar, they have the blood pressure or anything. All that is required, okay. So with all these things, what are we going to do? You have to, how to store the data? That's the next question. The first person, see, I have fixed up the features. I know how to measure that. I know what is the output, how to store this next, okay. Normally everywhere, even if a person comes to our home trying to take census, okay, you could have seen a sheet with the rows and columns, okay. Everywhere you see it is about the relational architecture, right? You have rows and columns. Always the column contributes to the attributes, right? The rows contributes to different variations. So that's where we end up with. So for Corona, this COVID data set, see, these are all what I am presenting. It's my own. See, I'm not taking from anywhere. You can have your own thing. See, fever contributes to one attribute, cough, breathing, tiredness, muscle, name, address, whether they are diabetic or not. Finally, whether they are COVID infected or not. So this is my output. Okay, how do we do? For the government, for all the patients who are checked up with these symptoms, okay, the final test result is what we are going to store on the last scale. By means of that, what am I trying to achieve? Okay, on a later date, okay, once this data set gets completed, the initial level of checking can be done with the machine learning itself. Okay, if you are contributing this for 1 lakh people, automatically, if you enter the details for this, it can tell you, the machine should be smart enough to tell you whether they are infected with the COVID or not. This will not be a final decision always. No machine learning or deep learning will give you a final solution. Rather, it's an add-on that is what to say, decision making for the expert, whoever you are employing. Okay, so, and what is the experience? See, this is patient 1, row 1, row 2, row 3, row 4. All these are what we call as the experiences. Patient 1 to patient n. This n varies. See, if you have 10 patients alone, it may not give you the answer on a proper scale. If you increase it to 100, it may improve. 1,000, 10,000, 1 lakh. Okay, so as and when you increase the experiences, it will improve. So is the experience addition alone will give you a better solution? Not always. So you look at the final, see if if you look at the healthcare data set, that is the biggest problem, right? So if for a cancer patient, if 1,000 are going for checking, only 10 hardly or 100 to a max will be infected with cancer. So you'll have a bias. You are trying to train the system mostly towards the negative side. That is to tell that a patient doesn't have cancer, is not infected with cancer. Okay, that's all is the problem with the data set, which once if you have experience, you can rule it later. So finally, what's understood is any data that you want to collect on a real time will end up with this kind of data set. This is what we call it as a data set. Okay, nothing more than that. Data we are accumulating in sets, which is called as a data set. So this is one another data set for forest fires. Okay, so the X, Y, month and a day on which it is happening, and so many different parameters. So whatever you say as a data set should be able to get loaded onto a Excel file, be it in the form of an Excel, CSV, or data file, or anything. So what is trending today? As of now, what we have seen is just an introduction of what machine learning is. How is it different from your traditional programming, and how should you consider the features for development and come up with a data set? Okay, so you have a data set. Now the next question is whether to move on to a machine learning or a deep learning, or what all AI is about. Okay, we won't say that all are different, because when you say artificial intelligence, all that it includes is, earlier it was only rule based AI. There may be a lot of explanations over that, but what I would say is very simple. It's a rule based technique. Okay, so rules, if then else, we cannot write always on an exhaustive manner, but if you write it on an exhaustive manner, it becomes artificial intelligence. You are trying to enforce intelligence to a machine through a set of algorithms. So initially, if you take fuzzy logic and all, it's all rule-based algorithms. See, when I want to ask you for the feedback of this session, you may be in a dilemma to say whether it is good or very good. I won't say on the negative side, always be optimistic. So it's, if my feedback, if you are on a dilemma to say good or very good, if someone says good, doesn't mean that he don't want to give no very good. If someone gives very good, doesn't mean that they always want to give very good, rather it may be on good. So if you want to give an overlapping strategy for that, in trying to introduce the mindset of human being through a machine, we call it as artificial intelligence. Okay, but the understanding of machine and deep learning is very important. So when to use machine learning and when to use deep learning, what is that you are trying to enforce from that? Okay, a simple example for text 5 to 10 minutes is there. So what is this? How does this look like? Can anyone tell me what is this diagram? How does this look like?
Classroom.
Yes. What
Classroom
kind of
teaching.
classroom is it?
Chemistry.
Pardon?
Science class.
Okay, fine. Okay, this happens to be a classroom environment, which we are not fortunate to have for the past 7 to 8 months. Earlier, we are fortunate to have this kind of classroom where the intention of the teacher, or what the teacher can gain out of this classroom or a traditional classroom is the listening skill. See, any teacher can able to understand the listening skill of each and every individual. Okay, for sure, by looking at their eyesight, and lot many different performance metrics are there through which you can understand, right? So their interest areas. See, not every one of these kids who are attending our session will be with the same interest area, but the teacher will be able to identify the different interest areas through interaction and lot many different means. Okay, their understanding level. So we cannot say that everyone will, or their IQs on the same level, and based on that, this is also possible. Finally, the style of learning. See, somebody would be good at visual learning. Somebody is very good at practical rather than theory. Okay, there are different kinds of learning styles: auditory, kinesthetic learner, visual learner. Okay, and so many things are there as discussed by this millennial. So everything the teacher can observe very perfectly from a traditional classroom environment. Okay, so by using that, what is happening? So all that what we require is to make the students who are learning the session to achieve a greater height, nothing more than that, right? So what is that I also require now? Okay, so if the takeaway of this session is to make you learn machine learning and to implement at least one data set through an algorithm, that is my achievement. So everybody will have their own decision. So initially, but it cannot be achieved initially, right? So the kid, when they are performing their exam, okay, they'll be at this level. So what we do, we'll try to identify what is the problem that may happen with this kid. So we have quality circle meeting, result analysis meeting. Okay, we have counselors, everything. We'll try to think, plan, and act. So suppose if he is more interested towards practical, you may give more examples. If he is memorizing and he is good at memory, you may give a lot of, see, it depends. Okay, so whatever we do at each and every training, after each and every training, they may able to achieve the next step. Okay, so that's all. Automatically they will be able to achieve the next steps. Finally, they can able to achieve the greater height, which is actually required for the kids. Here, the task is to make the student achieve greater success in their life. Okay, how this is being done, that's most important. It is through the teacher who is trying to acquire the characteristics of the student, trying to make them improvise at each and every step to achieve the particular task in a better way. Okay, so what is finally happening? See, these are all the techniques that you do have. That is, these are all the understanding that you have about a particular student, and these are the measurements that the teacher is taking. Finally, you are reaching greater scale through this particular measurement. But what is happening now? Okay, from the month of March, okay, so we are not able to meet any of you in person. Now you just you understand, if you are there in my all of the attendees are there in front of our, we can able to look have an eyesight with them, trying to understand what is good for them, what is bad for them, and what they are liking and what they don't like. Everything is we can understand. Okay, but okay, now the trend is slightly moving towards this kind of teaching, where the teacher sitting from somewhere, okay, trying to meet all the candidates through some virtual means, which is online learning. Okay, now again there will be a teacher. So I won't say myself as a teacher, a mentor. Okay, so again, can I know what is your interest area? It's not possible. What kind of learning? See, are you interested in my lecture, or do you want to straight away take move on to hands-on session? Whether I know, I don't know. Okay, so nothing, anything. What kind of learner are you? Nothing. So can I able to understand your physical presence? Nothing we can able to understand. But what is expected? Okay, this is a virtual classroom where the teacher is still there and the learning is still there, but nothing can be able to get understood from this virtual environment. Okay, but finally what is required is to have an achievement of this kind. Okay, be it your traditional classroom or this virtual learning environment, what is expected from the community is, somehow or other, I want to make you learn what I am trying to convey to you. Okay, so that's level of success. See, the level of success may not be same for all who are attending. Okay, somebody may be at this point, somebody may be at this point, somebody may be at the peak. Okay, it differs. We cannot always say that everyone has to be on the 100% achievement. Okay, so how to do that? How this is being done? Is everyone is interested in? No, the entire online community is not interested in knowing how this is being achieved. Okay, finally we want only an achievement. What I expect out of this workshop is, you should give a better feedback. Okay, not by the way of what I'm telling. Rather, you may be somebody may be liking my presentation, somebody may be liking my hands-on session, somebody may like the way I'm talking. Okay, all that, or somebody may be for the VIT brand. All that, I don't know how it is being done. What I need is how to have a success. Okay, the same, be it your traditional classroom or your virtual classroom, this is what is expected. Okay, now, so these are all the skill sets with which we are trying to achieve that. So earlier, previous environment, traditional environment is teacher centric, where the education and qualities are the matter. Each and every quality of the student will be understood by the teacher. It is teacher centric. Okay, so it may have its own advantage, it may have its own disadvantage. Okay, so but nowadays this virtual classroom environment is learner centric, wherein the learner is free to choose their own domains. Okay, so you choose the features which you like from me, you choose the features that you don't like from me, and go for alternate sources. Okay, it's all learner centric. But be it teacher centric or learner centric, what is happening at the end is nothing but a learning. Okay, why I'm telling, what is the difference between all these things, why I am concentrating unnecessarily on this, you may have a thought. So what is happening with when it is teacher centric is a machine learning. Okay, you can compare very well to a machine. Here teacher is more important, this algorithm is more important. Okay, and the data scientist who is going to pick up the entire features that are required for developing a particular environment matters a lot. But here, if you look for learner centric, it's more of a deep learning, right? Where will be trying to flood you with a lot of materials. I can give you PPT, I can give you Python notebooks, or I can give you audio or video or whatever it is. Okay, it's up to you to choose. Okay, you prefer, you go, you train with anything. Finally, I want only the end product. I'll conduct you an exam. You have to tell me whether you have to get a good marks. That's the only thing that is about this deep learning. Okay, so in short, what is happening in deep learning? This diagram better explains that. So we are looking at only the interface of the machine. Okay, so what is happening at the back, we don't know. Okay, so a better quote that we can say is leave everything to hands of machine and be relaxed. Okay, so that's the motto of deep learning. If you want to move in that aspect, it's better to go for deep learning. Otherwise, you can stay with machine learning itself. Okay, so in short, the learning requires materials, understanding of different learner styles, and once this materials and this understanding happens, and after delivery you'll be doing a result analysis, and after result analysis we'll go for improvement strategies, and then any innovations that you can add is always welcome. And finally, our intention would be to how to reduce failures to achieve a better result percentage. Okay, trying to map this learning with machine learning. Okay, what is the materials that you are supplying are nothing but the inputs, with are nothing but the experiences. So who is going to select the features? It is by the data scientist. Okay, the data scientist use you and me. If you are developing a machine learning solution, you identify what are the features that may contribute. And how to measure the performance of the algorithm? The algorithm will give you an output. Its performance will be measured by a performance metrics. Okay, somebody will say confusion matrix, somebody will say what to say, your that is root mean square error. Okay, so their accuracy is 1%, and F1 score is another. So many performance metrics are there. We look at the performance metrics, we see whether it is comfortable or convincible or not. If not, we go for adjusting this hyperparameter. What is hyperparameter? If a student gets low marks, we'll try to boost them by giving assignments and so many other things. So every machine learning model has some parameters which you can tune, because inputs you cannot change. The structure of machine learning algorithm you cannot change. The only thing which you can change is nothing but the hyperparameters, the set of parameters that can be adjustable to make the environment better. Okay, that's what we call it as the hyperparameter. And this model analysis, see, I am tuning everything. I am trying to rerun the algorithm and I am trying to get the performance. Still, it is not convincing. It's going very low. So what I will do, I'll try to go for another modeling. I have chosen naive Bayes. It's not giving me a proper solution. So I'll move for SVM, support vector machine. That's what we can do. Finally, this regularization, it is to reduce the failure. If you are an expert user, you can go for this. Otherwise, that is not required. Mapping the same with deep learning, nothing will change. Your inputs remain. Instead of the features selected by data scientist, here what the deep learning model will do, it will try to identify the features by itself. Like how in this virtual environment, all the features that is will be identified by the learner. Here also it remains the same. Nothing else will change. You have performance metrics, you'll have hyperparameters, you have model analysis, and you have regularization. Okay. So when to use machine learning, there are some restrictions. You cannot say that I have 1 lakh data of temperature in Celsius to be converted to Fahrenheit, and for that I'm going to use machine learning. So that's not the way. So only when there exists no statistical direct translation of your inputs to output, that only you have to use. So the entire thing states that if it consumes too much of human competence, so when you end up with a lot of waste of human resources, we can go for machine learning. Or if you think it is too complex for a human being to understand, since no direct statistical computation is there, you can go for using machine learning. Okay, so there are normally 2 skills. So this one everyone should understand before getting into machine learning. One is on the nominal. See, all the measurements that we do have can either fall onto nominal scale or on the ordinal scale. Nominal in the sense, actually there won't be any relation between one to the other. Okay, let's say if I ask you to fill up the data set with the sex of the person, male, female, okay, or anything or other. Okay, so now it's not there is no relationship between male or female or other. Okay, so all stands independent, so that way we call it as nominal scale. Ordinal is on the other scale where you have relationship between the attributes. Okay, suppose the feature attribute, okay, states whether the feedback of this session, let's very high, fair, bad, or very bad. Okay, always there exists a relationship between very high and high and fair. Okay, if you have the difference between those things, we call it also on the ordinal scale. And the algorithm also, so only in machine learning there are different kinds of scaling also are available, ratio scale, interval scale, but these two are the only scaling that are permissible in machine learning. Okay, coming to different type of data, fine. This is the first one, we call it as the structured data, where you have features A, B, C, D, E, and you will have entities. First row one entity, second row another entity. Okay, it will be in a structured format. And since it looks like more of a DBMS, whatever operation we can do on a relational database, the same we can do over here. And this is unstructured data. Okay, unstructured is like all that you are giving a review, product review. Okay, all that we do on a social media or a tweet or everything is what we call as an unstructured data. But even though if it is an unstructured data, we'll be trying to extract the features from here, and again it will go back as a structured data on a final stage, which we won't do, rather the system will do. So any type of data can be of interest. The first one falls under structured and the second one falls under unstructured data. So what are the different formats you can store? You name it, you can store. Okay, nowadays no algorithm is supporting only a limited thing. Anything you can store, but later on the conversion matters. If you want to store it in the form of an images, the pixel value. See, you take every pixel, the characteristic of the pixel becomes an Excel sheet, right? What is the red, green, blue? It follows RGB coloring. What is the red color? What is the green color? What is the blue color? If it is CYG, okay, cyan, yellow, green format, that also, everything. So anything will be converted finally back to an Excel sheet. Okay, since this data formats are evolving, algorithms are also evolving. It's not stopping at a particular point. Okay, and basically we have two types of data in machine learning. So if you end up with a range of values, let's say you have 1000 rows, okay, 1000 entities you do have, and these 1000 entities, if you look at the values, if it gets distributed within a range, we generally say it is infinitely finite, meaning that you may have an exhaustive value, but even if you have an exhaustive value, you can figure it out on a particular interval. So let's say the marks of a student will fall between 0 to 100. Okay, that is the range. The age of a person falls between 0 to 100. Okay, actually 100 is not any deadline. Okay, you may go beyond 100, but again, even if a person is there living for 105 years, that is an exhaustive finite set. Okay, so that is called continuous. Continuous means you will have values, any kind of value in between the range. Rather, if I say that, let's say nowadays no student is given a mark, rather it's a grading. Okay, what is the difference? We will try to map a group or a range of data or a value to a particular grade. So if you are representing marks, that is continuous values. If you are representing grades, that is discrete value. Okay, so how these discrete values are coming up? It is by mapping this continuous values from a particular range over a particular data. Accordingly, the algorithm varies. Okay, so if you have continuous values, we have prediction algorithm. If you have categorical values on the output, we have classification algorithm. Okay, so basically, if you take machine learning, there are two kinds of algorithm. Basically, it is three, but basic algorithms are supervised and unsupervised. And the third one is ensemble learning, which is an improvisation over the supervised or unsupervised. So what is supervised? Again, supervised, it is regression or classification depending on whether you have continuous values on the output or discrete values on the output. Okay, so to understand this better, okay, I'm showing you a group of people over here. Okay, so now yeah, I'm having a group of people over here. So this, if you look at this itself, we can say, see, the characteristic of these kind of every human being can be stored: the name, age, the address, and the education. Okay, how much salary are they getting? Everything is common to all the people. But finally, you will have a column called W, which represents the color of this color of the shirt that they wear. Okay, so if you look at this, automatically we can able to see there are three classes. Okay, one wearing yellow shirt, one wearing a red, and another wearing blue. Okay, so when you look at this, what kind of different operations that you can do, since it is categorized. Okay, this is categorized into yellow color, this is blue, and this is row. We can calculate average weight of all in a particular group. How do this group gets formed? It is based on the color again. Then you may calculate the average salary for this group. Okay, you can designate the group with the shirt. We see blue may refer to hospitality, red may refer to electrical department, yellow may refer to a reception. Okay, like how you want, you can have. Okay, so this, if you have this kind of the environment, okay, where you have the inputs followed by an output. What is the output? It is the color of the shirt that you want, or you may have anything over here. Okay, so we call it as a supervised learning. It is like having inputs and an output. I have shown you a COVID-19 data set. It's a supervised learning data set, meaning that you have an input. What is that input? Whether there is a fever, all the attributes that correspond to that. What is the output? Whether the patient is infected with corona, whose output is yes or no. Okay, since there can be only two values, yes or no, it comes under classification. Okay, that we need to be very clear. Initially, any data set, if you say, you have to be able to be clear on this aspect. First, we need to understand whether it comes under supervised or unsupervised. How to do? Supervised will have a set of inputs followed by an output. If it is unsupervised, you won't have any output column, rather it is all data. Let's say if an NGO is trying to capture only the values that they are taking for test. Okay, rather the test result is kept confidential. I don't know what is the result. So what will happen? We won't have any output column. Rather, it is all consolidation of only values. So supervised learning will have inputs followed by the output. Unsupervised learning, it will only be a data. You won't have any output. In supervised learning, again, we have two categories. One is classification. If you have COVID-19 result as yes or no. Okay, so you have only two broad categories or labels. The other case, if you say how much is the infection probability, let's say, okay, if it is the infection probability is 50%, 60%, or 55.2%, say, that comes under regression. If it is a number, it is a regression. If it is a classification, you will have designated labels. Okay. Coming to unsupervised, if you look at, if I'm giving you this diagram, can any of you tell me what you can do with this diagram? I'm just giving you this diagram, that's all. What can we do with this diagram? Or picture, I'm giving you this picture alone.
To identify the male and female,
yes,
and to identify the colors.
First is you can categorize the entire group into male or female. That's one way. Another thing? Anything else? Any other possibility?
Do you have caps, caps and without caps?
Yeah, those who are wearing cap and those who are not without caps. Then
color identification.
Color, okay, color, maybe the skin
colors.
color or maybe the shirt color, anything. Okay, so when a picture, this is what is unsupervised learning. I'm giving you some data, but I'm not telling you what I'm expecting out of that. What is the output? Okay, it's just a data that you are having. So according to your interest, see if somebody could able to equally see that there are enough number of male and enough number of female over here, that may gain more importance, and you can divide it into two groups. Fine. But if there are too many people wearing caps and only a few is not wearing, again, you can have a segmentation. But whatever you say, whatever answers you told me, thank you for all those. So now what you have done is segregation, right? Is that anything else that we can do? Is that anything else that we can do? Is that all about segregation or segmentation?
Some are wearing a different color of caps.
Yeah, that's what. Whatever is that. Okay, what we are trying to do is divide this group into n number of subgroups based on one criteria or other, right?
Yes.
Yeah, that's the only operation that we can do, and that is what we call it as clustering. Okay, here what I have given, these are some of my perceptions. Okay, I can divide the entire group based on the age, based on the color, based on the height, okay, whether they are, and based on the sex, male or female, as you told. Okay, but all that, what we end up is only clustering. No other operation is possible on an unsupervised data set, because all that we can do is try to merge these similar entities into one group, okay, and try to figure out them with the appropriate label, okay, because we are not telling that this is the label and that is the label, okay. The system has to automatically come out with the label as how you are telling that there may be white colored gaps, there may be red colored gaps, and there may be somebody without gaps, okay. So that's what is the intention of unsupervised learning. So these are the some of the algorithms in supervised learning. Supervised, we mean you have inputs and output. Again, you have two categories. One is regression, another one is classification. Most of the algorithms will support both, okay, regression as well as classification. So if you take decision tree, we have regressive trees, we have general ID3 classification, because any regression, when you the final output gets confined based on a range to a label, we say it is an a classification, okay. So this linear regression is what is existing as the base model, and what this IIT professor was talking yesterday. So we'll be trying to plot a straight line mapping all the points on the space, okay. That is about your linear regression. That is for supervised regression model, okay. All other support vector machine, on the other hand, perceptron and support vector is for non-linear methodologies. If you couldn't directly find what is the linear map, any linear mapping between inputs to output, we go for non-linear algorithm, which is, that's what is about this K, okay. And most of the unsupervised clustering algorithm requires this K to be given, that is predicted by the human being, but based on the result that you are getting, you can optimally get this K. So these are all some of the algorithms. So combining all these things, we have ensemble learning. Ensemble means that is improvisation over the existing algorithm. You have base algorithms as supervised and unsupervised. And when we employ improvisation over there, you have random forest. Random forest, as the name implies, what's a forest? It is nothing but combination of trees, okay. The tree is formed using decision tree algorithm. You form a tree using decision tree, and then you have multiple decision trees put together randomly, and that's what is random forest. Add a boost, employ any algorithm and try to boost it. When do you, Sachin Tendulkar always says, boost is the secret of my energy, okay. So whether we'll be taking boost all the time, not necessarily, right. Whenever we feel we have to have an energy, okay. So, and we have loss of energy when we go for taking boost. The same way, when we run an algorithm, if it is, if you are not able to arrive at a particular accuracy level as what we have expected, we go for boosting, okay. So boost is not only the available concept, you have Horlicks, you have Bonvita, and so many things. Likewise, the same boosting is done by different algorithms, ADA boost, XG boost, and different boostings are also available. In selection of yes. Okay, fine. Some other noise. So I'll stop the theory session with this slide. Okay, so this is just a comprehensive look at how the modeling process will go on. So you have real world entities generating data. Okay, there is no restriction on what will become the data and what not. Okay, so now if a child is crying or shouting near me, that also could be considered as a data.
Arun, he'll ask Pramila madam if by any chance she have.
Yes, am I audible?
Yes, Suganya ma'am, you are audible now.
Yes,
I pressed unmute.
Yeah, no issues. So this real world entities
because there was some
data
noise.
gets generated. Once the data gets generated, automatically we have to identify what becomes the prominent features according to the domain of interest. Okay. So since every individual is creating a data, it's not that the data will be proper in all sense. Okay. There may be some loss of data. See, let's say if a patient is coming for an COVID test, okay, he may not know whether he is diabetic or not. So you cannot fill no over there because we are not sure whether he has a diabetic or not. Okay. So we'll be leaving it as a blank. So that's where we end up with pre-processing on the initial stage. So when we are collecting data from real time, so the data may not be proper in all the sense. So we have to pre-process in multiple stages. The important being first is your missing value analysis. What to do with the missing values? Some fields, if it is left empty, what are you going to fill up with? Are you going to see, let's say, the presence of diabetic is given by 1 or 0. 1 means a diabetic patient, 0 means a non-diabetic patient. If you just say that all the empty values are filled with 0, it may affect the end result. Okay. So how are you going to do that is the pre-processing technique. Yeah. Somebody has doubt, I hope. Is it so? Okay. So once this second important pre-processing is normalization. So, okay, the reason being all the features that you have will be measured on a different scale. Okay. Fever is measured on one scale and your presence of what to say, the breathing problem is measured on another scale. The scale varies from one to another. Okay. In order to bring in a standardization and to look at visually proper. See, the units may be from 1000 to 2000 for one data, one feature. It may be from 0 to 10 on another. So visualization becomes a problem. And for that, we go for normalization wherein the entire data will be converted onto a 0 to 1 scale. So once this pre-processing is done, see, there are many, but to start with, these two are the mandatory pre-processing techniques. And once this pre-processing is over, we go and see whether all the features are important. Okay. So generally, if you have the look at the Corona COVID data set, the name and address of a person may be important, but it won't directly contribute in deciding whether the patient is having COVID or not. Okay. But it is information that should be recorded for some other sake. So these unwanted features, if any, has to be reduced using this dimensionality reduction. If you feel like all the features are important, directly you can go for training the model. So identify the algorithm based on, so the initial level being find out whether it is supervised or unsupervised. And based on that, if it is supervised, you go for checking whether it is regressive or classification. So you train it using the selected model. Training means based on the algorithm chosen, you give the inputs and outputs, the system will try to understand by itself. And finally, training alone will not give you proper answer. You have to test it for validity. Okay. So without testing, we cannot see. If I ask any student to write a program to compute factorial of a number, it's an implied concept that he should have tested his program by giving some sample inputs. Okay. No one will tell that it has to be done explicitly. So training, if it is so, has to be tested. So normally the testing will be done by using the same data set which is used for training. Sometimes it may go on 80-20 scale, 70-30 scale, but at times the entire data set can also be used for training and then for testing. Finally, analyze the result. If the results are convincing to you, proceed. Otherwise, go back, change your model, and then train and then test. Okay. So I hope this is a comprehensive view of how you can visualize your data set and all. So I'll just move on for this thing like one.
Excuse me, ma'am.
Yes, ma'am.
Do we give the same data what we used for the training for the testing?
Ma'am, there are multiple ways. See, let's say you have only 100 data, 100 experiences. Okay.
Okay.
So one way is initially to start with all the 100 rows can be used for training and all the 100 can be used for testing. Okay. And you can compare the accuracy. That is one way. Okay. But generally, the standard convention is to divide your data set into 80-20 proportion. 80% of randomly picked training data will be your input data will be used for training and 20% will be used for testing.
Okay.
But if you divide like so, you may always, there is a chance to get into an improper segregation, right? Because it is also random. So that's where, if you want to be more specific, we move on for cross-fold validation.
Cross-validation, okay.
Yeah. Divide your data. So if you go for 80-20 rule, divide it into 5 different divisions. Use the first 4 for training, 5th one for testing. And then use the first one for testing, rest 4 for training. Likewise, we rotate and find out. So to make the data set more comfortable, validation, that's it.
Okay, ma'am. Okay. Thank you.
So coming to from where and all you can identify, where and all you can get the data sets. This is the first popular repository that is available, UCI machine learning repository. So it has thousands and thousands of data with that. Okay, here itself you can check for any electrical power system data set also. Okay, so if you open anything, let's say if this iris data set is the highest number of data set. If you open it, it will automatically tell you whether it has missing value, how many number of attributes are there. Okay. And what is important is what kind of task you can do. It is the classification, meaning that it comes under supervised data set. If you get into this data folder, automatically you can download this. It is in the form of a data file. Don't worry about it. If you download it, open it using Excel, automatically it will open for you. Then comes Kaggle. Kaggle is another machine learning repository. Now this is getting more power than anything else. It is a competitive machine learning environment where everybody who is trying to get the answers will try to post lot of. When I open itself, you can see COVID-19 worldwide testing data. Okay, you have hundreds and hundreds of data that will get added on a minute basis. See, if you open it, if somebody wants to conduct some competition, they will give here. Okay, and the best part is that the basic the execution of the algorithms will also be given here. If I am contributing one work over here, automatically you can just view as an initial beginner and then you can move on for that. Okay, and in general, if you Google dataset itself, especially for power systems, yesterday when I was looking at, there are a lot of different data sets that are available. Madam also, Hema ma'am also gave me something, this OpenAI data set. If you go, there are different data sets about the grid, which is taken on hourly basis, a daily basis and all that. Okay, all that what you need is only a data set, nothing more than that. So you don't need to worry. With that, what you can do, once you fix your data set, you can go for installing Jupyter Notebook if you are good at, if you want to work with Python, which is more comfortable, we should say. Just you can, instead of installing Jupyter or Python individually, you can install Anaconda. Okay, Anaconda is a wrapper. So Anaconda is actually a wrapper which comes with inbuilt Python, Jupyter Notebook, everything installed. Okay, so just you can go here, you can install. It's completely open source. You don't need to bother. So all the packages will be installed. When you download here, Jupyter Notebook automatically will come. Okay, but you may have a question of why should I install this? What if I don't want to install on my system? Yes, Google has come out with the collaboratory. Okay, Google Colab. Okay, Google Collaboratory. So it's a cloud-based environment which you have to log in using your Gmail ID. Okay, there also if you open, automatically it will give you, see, these are all the ways you can use it. You can go for looking at examples which people are giving. Then what are the reason? You can download any Python file from Google Drive, whichever we have. If you have GitHub associated, you can directly take, or you can upload a file from my machine to the Google Laboratory. Okay, whatever be it, if you look at, this is a cloud-based platform. When you want to work without installing Jupyter Notebook, or when you have trouble in installing any Jupyter Notebook, the biggest advantage here is that Normally, our systems won't support execution in a faster pace when your data goes on a higher scale. Okay. Now here you can support this particular collab support. See here, if you look at here, this hardware accelerator, we can choose even GPU or TPU. GPU is graphical processing unit, tensor processing unit. So all that is free of cost from this environment. Okay. So you can execute and you can leave it and you can get back the result in a very quicker pace rather than our system. So anything and everything, this Jupyter notebook is of interest to us. And this is how it will look like. When I open a new file, you will get to have an environment. See, my system is very slow rather than your Google Colab. Okay. Now you'll have an environment of this kind. The biggest advantage with Jupyter is that the input cells can be segregated into two types. Okay. One is this execution cell. If I insert one more and if I want to write some comments over here, I can change the first cell to markdown. Okay. Meaning that suppose if I write, this is a sample. Okay, when I execute, see, this won't be get executed. This is just a comment box. Okay, and you can have codes over here. Import fly plot as PLT. If I write, this becomes an executable. Okay, so this is matplotlite.pyplot. Yeah. Now this becomes an executable cell, okay? And you have pieces of codes written on each and every cell. You can skip one thing. See, suppose here if I write import numpy, and even the next cell, suppose if I write print hi, okay? If I don't want to execute the second one, you can straight away execute this cell, okay? So all that is possible with this. Yeah, if you execute automatically, see, you can see the continuous execution. This is 1, this is 2, and this is 3. I'm not executing the second part. So this is very easier and comfortable environment for you to execute or start working on these things. Okay. So now I'll just show you in another 10 minutes about what are the different packages that is required for you to start with. So I'll just quickly move on. This is NumPy, which stands for numerical Python. So it's a very comfortable Python package that gives you all the numerical operations in a stretch. Normally in C we have math.h, okay, and in other Java you have again it is also embedded. So like the same way here it's NumPy. Okay, here all that is considered to be of an array, single array, and this is two-dimensional array. So how to do import NumPy? Okay, when I don't want to use this NumPy always, it is boring, and hence I'm creating an object as NP. This NP could be NP1, NP2, or your name as you wish. Okay, I have created an array, one-dimensional array. This is what sir was talking about vectorization yesterday. Whatever feature data that we have on a particular column becomes one vector. Okay, and this is 2D array. 2D array is also a combination of multiple vectors. That's all. Okay, split it across your rows. And here the attributes of the array you can get. Okay, so the type and then data type, what it has, shape. Shape refers to how many rows and how many columns do you have. Even if you extend for 3 dimension, you have 3 dimensions over here. And size refers to total number of items. And item size refers to how many size it takes to store one particular data. Okay. The number of dimensions refers to how many number of total dimensions. That is, row is 1 dimension, column is another dimension. If you go for 3 dimension, it becomes 3. The total number of bytes it takes. Okay, so we don't need to bother too much about it, but when the data set grows large, all that is important. Okay, and these are very easier ways of creating. See, if you want to create an array with all zeros initialized, okay, you can just create like this, np.zeros of 5, 2. With all ones, if you want to create identity matrix, you can create random arrays, random integer. This is floating point. This is between 0 to 1, and this is between or any particular range. If I want to have random values between 0.3 and 0.35, you can do. Okay. And this is another example. See, you can create array using this A range, just like that. So it takes 3 parameters: start value, end value, and this is step with which you have to have the elements. So from 1 till 10. In Python, the last value will always not be taken. So it will end up with 10, 9. Okay. So this is 1 is the starting value, 9 is the ending value, the step value is 2. Okay. So that's how it is. Just you can have a look at this for a minute. I'll have some water and come back. Just a minute. Yeah, thank you. I'm back. So this is another way of creating arrays. So np.line and space, line space. Okay, we say that we want to have elements from 1 to 10. Okay, 1 to 10, having 50 elements in between. So we are not talking about the space, rather it is about the number of elements we do have in between the range. So automatically it understands how much data, how much interval it should have between one element to another element. And the slicing is more important. It's a quite interesting way to, because you can have slices between unrelated rows and columns. Suppose if I want to have values from 7, 9, 12, 14, also it is possible. Okay, so that is about that. And masking, if you want to hide only a set of rows, that is there. And all the aggregation methods that you want to employ, it is there. Okay, I'm just showing an overview of that. So this is the first package that we should learn. And not see, and nowadays it's not that any method needs to be memorized or anything. All that is supported by Google. But only thing is we have to have an overview of what is actually available, so that comfortably we can choose between the methods. The second package, which is most useful, is the pandas. Actually, pandas is nothing but an object which takes the entire matrix in a single case. That's it. Okay, you have a matrix. What is a matrix? It is an Excel file. These pandas takes this Excel file as an object and works on it. That's all. Very easier and quite easier way. Here, what I did is I'm going to create a matrix, okay, having English, Maths, and Science marks of 4 students. So the list 1 is S1, S2, S3, S4, which will be on the first column. English marks on the second column, Maths on the third column, Science on the fourth column. Okay, you can see here. This is how it will be created. Okay, if I convert this into a data frame, what is a data frame? It is nothing but an Excel file, you can assume. Okay, so it goes like this. So it's very easy and quite easy. You have 4 columns: ID, English, Maths, Science, and you have 4 students that are indexed with 0 to 3. Okay, so it is very easier to import a CSV file onto a data frame. All that we have seen just now is you can download dataset from UCI, Kaggle, or any repository you have. But how do you import this dataset onto your Jupyter environment? See, if you write CSV, automatically I have stored this dataset over here. You can load it. You can load an Excel file, or if you want to directly take it from an online environment, you can take. Everything is possible. Okay. And once everything is over, you can save it back to the result can be saved back to the environment or any drive, whichever you want, using this thing. Okay, and this is creating indexes. And if you want to know about the information, okay, what are all the information? Generally, it is about what is the mean of a particular column. What's the maximum value? What's the minimum value? Everything you can get easily. Okay. And if you want to change the column name, yes, you can do. If you want to strip down some columns, yes, you can do. So all that pandas give you in a single way. Okay. So that is the second package that we should be able to look at. Okay. Why are we telling that this Python is good enough rather than Matplotlib or something? It is because of the visualization. Visualization is far better compared to any environment over here. It supports variety of plots and combination of plots also. Okay, you can have multiple plots drawn over each other. Okay, this is line plot and this is also line plot. You can see this is also line plot. Okay, depending on the value, it combines. And these are also line plots, 2 plots drawn together. Scatter plot. Okay, so line plot, what is the difference between scatter and line? You will have connection here. In line plot, it won't be there. This is also scatter plot with grid lines. Okay, so this grid lines, you can size it. If you want to have grid between 0, 10 and all the points, you can have. And this is twin axis. This is one advantage. I don't know whether it will be supported in MATLAB or not. This X becomes a common attribute for this one and this two. So you have to visualize this chart by the way like this: X versus X squared, X versus X cubed. Okay, there are two charts. The value varies. You can see here. Onto your left, you can see from 0 to 100. Onto your right, you can see from 0 to 1000. So that is also possible. And you can have variety of charts of this kind. You can have different styles that is given here. You have bar charts, okay, and you have, this is also a bar chart with least size or the width, looking like a histogram, but it's not a histogram actually. When you have, you can combine multiple bar charts like this. See pie chart. Okay, pie chart, you can see here a very common, quite impressive way of representing the pie chart. See, if I want to represent, so initially when I draw this, it was the most COVID cases in America. I want to highlight it. So I have exploded only that portion slightly away from the rest of things. See, that is how good is this. This visualization is important, okay? How much ever effort we put, so that is not a matter. Finally, we should end up with a kind of thing. See, I want to represent artificial intelligence, machine learning, and deep learning using pie chart. This is a pie chart. I have overlaid 3 pie charts, one over the other, and that's how we end up with. This is a histogram, okay? And this kind of 3D charts is also possible. This is more useful for visualizing the data distribution and the difference between the predicted and the actual values. That's there. You have subplots. This is more useful in most cases. That is, you can have a number of graphs in multiple rows and columns. That is there. Okay. When you have vertical charts and this thing. And improvised form is what we call as Seaborn, where the visualization gets improvised. Okay, you could see here, you can have multiple charts combined together. This is a heat map used for correlation analysis. One quite interesting is to visualize this is like, so for the values distributed over here, you will have colors from white to black. The minimum value will be represented as black. The maximum value will be represented as white. Okay, and the values in between you can have, this is on red based, if you want to green based, a slight variation. Okay, by that easily one can visualize what is the kind of value that gets mostly distributed on that kind of visualization you can have here. And this is box plot. Okay, so box plot is normally used to identify the outliers. Okay, so who is an outlier? Let's say I'm giving a very basic level of lecture today. And assuming that all are at the initial stage of development, but if somebody is too expert, which feels it is boring, they are the outliers over here. Okay, they are the outliers for this context, but maybe of interest on a different context. Likewise, this box plots are very useful in identifying. So this thing, okay, and this is pair plot. Okay, you can visualize here. Multiple attributes can be visualized using this pair plot. Okay, so with that, I just have taken 2 data sets, and I'll show you that. I have applied linear regression on one data set. Okay, this is a simple linear regression. I'll just show you how we have done, and then I'll show you one electrical data set because that is not giving proper accuracy. Okay, so what I did is I have created a data set of my own having the year, okay, and the placement percentage. In year 2000, it is 50%. In 2001, it is 54, 2000. Likewise, the placement percent gets increased. And in 2019, it is 98%. Okay. So the first step always to identify whether I can go for linear regression or SVM or any model or non-linear model is just a minute. Yeah, sorry. So it is like, first we have to check the linearity. Only if there exists a linear identification between your input values, and linear in the sense there should have, if y is equal to mx plus c is the equation, there should not be any powers. Okay, if it goes like y is equal to mx squared plus mx cube plus mx power 4 likewise, it is comes under non-linearity, where this kind is not suitable. Therefore, that we can use scatter plots. Okay, so this is a scatter plot which we have used. You could see here, so the linearity can be matched by, if a straight line is being drawn, we just need to check whether most of the points could be matched on the line or not. That is what we call it as linearity. But if you feel like all the points needs to be mapped only on using a curved line, that means you are non-linearity mostly, for a very basic understanding. Okay, so this is like if I draw a straight line, okay, with minimal error. What is the error? The straight line is what I could draw, but the exact points are distributed somewhere. So the difference between the exact points and the point on the line is what we call as the error. Okay, so since it is more linear, okay, we can go for using what is a linear regression method. There is another way to identify this is using correlation. Okay, correlation values. Correlation tries to identify the relationship between your feature to the output variable. Okay, so what we did is, it is very simple in Python. So just by using this .corr, you can identify the correlation values. So all values that lies above 0.80. Okay, if it is positive correlation, positive means if one attribute is increasing, other will also increase. That is positive correlation. If it is negative, if one is increasing, other will decrease. That is negative correlation. If you couldn't find any relationship between these two, no correlation exists. So in the ways, the correlation value will exist between -1 to 1. And when you have values between 0.8 to +1 or -0.8 to -1, you can better go for linear regression. Here you can see it is 0.84 over here, between the year and the placement percentage. So now the execution of linear regression model, see the Python comes up with a package called sklearn, where or the implementation for the entire machine learning models are readily available. From sklearn, I'm just going to import linear model. Okay, so I'm just using linear regression package. Okay, so create an object which is regress. Now that, what is the training data? You have an Excel file. Now we have to divide it into input and then output. The input is the year and the output is the placement. So train X is what I'm storing as input. Train Y is what I'm storing as output. Okay. Now, once this Excel file gets divided into two components, which is train X and train Y, we can fit a straight line between these two using this. What is regress? It is an object created for linear regression method. So dot fit of train X. See, this fit will calculate the slope and the intercept for that, and automatically you will get a straight line connecting all the points between train X and train Y. Okay, you can see here the straight line equation, which was clearly explained yesterday. It was y is equal to mx plus c, where the m is calculated to be 1.94 over here, and the intercept is calculated to be -38.33 over here. Okay, and this is the straight line equation with to which, if you are going to give any new value as input, you will be able to get a new y as output. Okay, so now what I did is, I just have plotted. Okay, so the benefit is this: I'm plotting, okay, the both the graphs. Okay, this is the actual data, this is the value. Okay, straight line that we have fitted for the after training a regression model. Okay, these are the values. Actually 50 is our initial value, first value. It is, the system is predicting to be 60. So what is the difference or the error? It is the prediction minus actual, which is 10.05. Likewise, the loss or the error is being calculated. Yesterday he discussed about the complete loss function. So for every entity, the difference is taken And finally, we'll take an average, and that is what we call it as the mean error. Okay. Since we don't want deviation on the either scale, let's say actual minus predicted or predicted minus actual. Okay. So we don't want to give bias on that. So that's where we are squaring it in order to reduce that that is a dimension sign problem, and that's where we end up with mean square error. Okay. But if you square each and every value, the magnitude will go up, and in order to bring it back, finally we take root mean square, and that is that. Anyway, all the three corresponds to only the error finding mechanism. It is only here you can see mean absolute error is 4.7, which means around 95 point some percentage of values are correct. Okay, the prediction is correct. Okay. And if you, since we have squared, you can see a maximum value 53.55. And when I take a root of it, it is 7.3, from which you can come to know that the model quite okay like in fitting the data. Okay, the same if I want to visualize, I think I don't have the frequency. The same here, if you can see, I have taken one electrical data. Okay, this is the data set which I have downloaded. It has 4 parameters: time seconds, solar irradiance, ambient temperature, electric demand. Okay, this electric demand is assumed to be the output, which is depending on time seconds, solar irradiance, and ambient temperature. The same I have worked out using the same way of how I have shown you now. See, it is in an Excel format, and hence I'm using read_Excel. Okay. Once it is done, how many rows and columns I do have? It is 1441 rows and 4 columns, which I got from the shape command. And head corresponds to the first 5 rows of your data. Okay, just to check whether it is correct or not. If I want to get a complete information about it, I will use df.info. Okay, you can see here. And if I use describe, it gives you the data about the entire. This is more useful. What is the minimum value you have? What is the maximum value you have? And what is the mean of the values? Okay, what is the standard deviation? Okay, you can see over here the entire data. This 25% is like what is the mean value of the first 25%. You arrange the entire data based on as in ascending order of time seconds. Take the mean of that, that is that. Okay, so here I have drawn a pair plot for this Seaborn library. Okay, so using the Seaborn library between the solar irradiance and the electric demand. Okay, so I have one parameter called solar irradiance here and electric demand here. I want to identify whether there exists correlation between this and that. Okay, so that is done. That could be done using this diagram. You can see here there exists a correlation. Correlation means if one is increasing, either you should have an increase, or see if the data gets distributed here and there, that is no correlation. Otherwise, correlation exists either on the positive scale or on the negative scale. This is another kind of improvisation. See, in Seaborn, here I have drawn scatter plot, here I have drawn line plot. Both are also possible. Okay, and this is the correlation value. This we call it as heat map for visualization. The maximum value is 1, the minimum value is minus 0.2. You can see what are the attributes that gets correlated on a better way. The maximum value over here is 0.69. Okay, so where comes the 0.69? It is between solar irradiance and ambient temperature. That is, between the input values, there exists high level of correlation, but not within the input values and the output. Output is electric demand, you can see. So this electric demand gets more correlated only with the time seconds. Okay, as the time increases, you have an increase in time electric demand, but not with any of these. Okay, so when I run this model using linear regression, it should not give me a proper result. Rather, the error that exists in the data will be more. That's what is the understanding we should get from this diagram. And but I have done the same. And I have done missing value analysis. Just it is very easy. Is null of whether if there exists any null data, it will show you. Since this data set doesn't have anything of that kind, it is 0. Otherwise, it will tell you how many values are null. Okay, now I have divided the data set into training inputs and then outputs. Inputs means 0 to 3 means the index will start with 0, 0th column, first column, and then second column. Okay. So this is 0th column, first column, and then second column. All these three will be taken for train X. Okay. As I already told you, the last value will not be taken. The third column, third index. What is the third index? It is nothing but the electric demand. That alone is considered to be the output over here. Okay. So we can print the shape and you can see 1441 cross 3. 3 features becomes your training data and output is a vector, single vector 1441. Then we go for normalization. You can see here all the data gets changed to 0 to 1 scale. Okay, why? Because you can see a variation here. Here the values range on a different scale. The solar irradiance. Okay, this is on a different scale. Here it is 0 sometimes. Okay, it is 138, 137, 973. So it is different. This ambient temperature, see, everything goes on a different scale. So we bring in a normalization over here. And with that done, we go for regression line fitting. Regress dot fit off within a single statement. It will do between the inputs and the output. You try to draw a line. That's what is the meaning of that. And your coefficients will end up like this. So it is, you have 3 different input parameters. One is time second, solar irradiation and other things. So it is y is equal to m naught x, first this 3302 x1 minus 378 x2 minus 14393 x3 will be the output plus the intercept. Intercept is nothing but the overall bias in the system. See, when I have a class of 100 students, and I could see only 90 marks to be the best. When I try to give +5 for all the students, thus +5 becomes the variance for the entire data group. Okay, and that is what we call it as the intercept. Okay, you can see on the diagram here. Okay, earlier I have shown one diagram here. Yeah, we can see here, this is the intercept. Okay, so from where it starts on the initial phase generally. So that is the intercept that we have. And that will also be calculated using this. 247 is the intercept. So meaning that for the initial value, it starts drawing its line from the 247th y-axis. Okay. And we are predicting using, see here, I didn't have divided the data set into training and testing using 80-20 rule. Rather, the entire training data I have used for training and testing. Again, the same inputs, train X I am passing for prediction. I am printing both the values. See here, minus 630 is the actual output, but after prediction, we got only minus 445, which is drastically wrong. Okay. And hence, that's why I told, since there exists non-linearity, we should not get proper output from the linear regression. Rather, we should go for a SVM model or any non-linear. See, it is like, we can't say in machine learning that this will perfectly suit and that will perfectly suit. It's all on the trial and error basis. Okay. Now the same I have visualized using a 3D chart, and this is actual value and this is predicted value. By looking at this itself, we can able to understand that the relationship, the error value will be much more, which makes us not to consider this modeling for that. But this is an overview of how you can visualize and employ linear regression over this. Okay, just the part which you need to make goes change here. I have used a linear model. If you want to use any other model like decision tree or Naive or SVM or Perceptron, only the corresponding package you need to import. Nothing more than that you need to do on the initial stage. So just try changing the model and try to assess the output. Okay, so that is one way. I'll end up by taking 2 more minutes. Just I'll show what we did here. This is a plant generation, plant 1 generation data. Okay, I'm not good at your thing. That is on a daily basis, some total yield of a particular power plant is being taken. Okay, so there are different plant IDs available. Okay, or daily from n different plants, that is electric power generation plants. The DC power, AC power, and daily yield of how much it is giving is being taken, and the sum of these things will become your total yield. So I just have visualized it, not more than that I tried to do. Okay, just to want to show you what are all the things that you can do. Actually, I have first imported the data onto the Jupyter notebook using this. We could see the size of the data. It is 68,778 into 7 rows. Okay, and I have printed the information about this. And here what I did on the next time is, I'm going to divide this date time into time and date separately. Okay, so it's all to show that it is very easy and convenient to use Jupyter Notebook. See here, plant, what is that I'm going to create is a new column called time. So plant one data is the name of the data frame. I'm going to create a new column called time because initially it was not there. You can see here, there are only 7 attributes, date, time, and it ends with total age. I have shown you the data set also. So I'm going to create a new column called time. So only thing is we have to segregate the time part of it and you have to give it. Okay, that's what we did. So we are converting it into time. We are converting it into date. Okay, so automatically the system will retrieve that for you. Don't need to bother. Just this is a visualization of how data gets distributed. See, here, actually what we have plotted is between time and then DC power. Time on the x-axis and DC power on the y-axis. That is the plotting we did. The style is the dot. If you use star, automatically you will get star. Okay, star thing. The figure size you can check. And this is one way. If I execute this, it will give you 2 diagrams. See, this is grouped by the mean of the DC power. Okay, so if I want to find out what is the mean value based on the DC power at 0, what is that? You can also find the mean. Okay, if I change it to sum, you can see a change in value here. Okay, see, you can see a change in value. Okay, since so likewise you can visualize in a different scale in a very easier way. I'm not good at understanding this data set, but rather I took it from a Kaggle data set and wanted to show you. That's it. Okay, similarly here what we did is on a particular day, on a particular time, how much is the total yield that it has come? Because if you look at this data set, this is a very exhaustive data set which has multiple time periods. Let's say if I want to have only January 6th, 0 minute. Okay, this much data you have. My intention might be to understand how much would be the total yield. Okay, so it is very easier over here. See, what we did is used a aggregation operation, which is on the aggregation is the sum. If you want to have mean also, you can have. Accordingly, you can visualize it. Okay, so these are different styles of visualization that we can have. How the data, see, from 0 time, how the plant generation gets improvised as the time gets. See, by the end of the day, the generation is much more. So that's what we can able to understand. So these are all simple visualizations with which you can identify whether the presence of a particular column is important or not before proceeding with the selection of your machine learning algorithm.